Now we'll study box plots. Sometimes they're known as box and whisker plots. They're made by something called a 5-number summary. You take your minimum, the lowest number, and the maximum, the highest number. From there, you find the median, also known as Q2. Don't count the Q2, but divide up what's left so that you would be finding everything going upward, and that will be the middle, called Q1, and then dividing everything from that median, not counting it, going downward, that will be your middle, called Q3. However, different books will present it different ways. Some would have you use Q2, some would not. For our purposes, we will not use Q2 in our counting. Let me give you for instance. If we have the number set 1, 2, 4, 4, 6, 7, 7, 8, 10, 10, 10, and you're asked to find the 5-number summary. The first number is 1, and the biggest number here is 10. Even though it's repeated, the biggest number is 10. Then we have to find the quartiles. So in our data set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So the middle will be the 6th piece. 1, 2, 3, 4, 5, 6, leaving us with 1, 2, 3, 4, 5 on the other side. So our middle number, also known as Q2, is 7. Now I'm not going to use Q2 in my counting. So there it is. I'm going to cover it up and see what's left. When I see what's left, I have 1, 2, 3, 4, 5 pieces of data. 4 would be the middle. So 4 would represent Q1. Going the other direction. There's my median. Cover it up. I have 1, 2, 3, 4, 5 pieces of data. The middle number would be 10. That would represent Q3. So when I plot that on a box plot, there's my minimum and my maximum. If I think of this as a number line from 1 to 10, 5 would be about in the middle. So 4 would be around here. That would be our Q1 number. Q3 would be 10, which makes me have to stretch my box. So it goes all the way to the edge there because Q3 and the maximum number are the same. That's okay. And then we have the median, which is 7. And I plot that in. It's going to be about there. Label it. And I now have my box plot. However, there are still pieces that are missing. They're called fences. That'll tell me whether or not I have outliers. The formula for finding these fences is based on something called the IQR, or interquartile range. Range being max to min, so when I do interquartile range, it will be Q3, the max, and Q1, range meaning subtract. Interquartile, so between the quartiles, what's the range? How big is the box? The outlier formula is based similar to that, except it's going to use Q1 and it's going to subtract 1.5 times the IQR. The upper fence would be Q3 and it's going to add 1.5 times the IQR. So let's use those formulas and go back and finish our fences on example 1. So my fences, the upper fence and the lower fence. The lower fence is gotten by the formula Q1 minus 1.5 times the interquartile range. One more time, the interquartile range is the same thing as Q3 minus Q1. So our Q1 number is 4. So I'll put that in the Q1 spot. Minus 1.5 times Q3, which is known as 10, right here and here, minus Q1, which we already labeled as 4. So I will compute this and get 4 minus 1.5 times 6. 1.5 times 6 is the same thing as 9. So 4 minus 9 is negative 5. So on my box plot, which is based off of a number line, I would put a fence, think of it as an open parenthesis, at negative 5. If I had any values that were less than negative 5, then by definition I would have an outlier, and I would mark it with an asterisk. My data set does not show anything less than negative 5, so I have no lower outliers, but I have to check the upper outliers. And I do that by finding the upper fence. Its formula, Q3 plus 1.5 times the interquartile range, which is the same thing as Q3 plus 1.5 times Q3 minus Q1, because a range says subtract. Q3's value was 10, no matter which way you look at it. 1.5 is part of the formula. The range went from Q3 of 10 to the bottom part of the box, which was 4. So I have 10 plus 1.5 times 6, or 10 plus 9, which is 19. Kind of out of room on my box plot, but if I were to put that number in as best I can and still have it fit on the screen, I would have a fence at 19. Nothing showing outside the 10, so I do not have to mark it as an outlier with an asterisk. So let's try another example. My 5-number summary should come fairly easily. Here my lowest number is 10 and the highest number is 18, the min and the max. I have 1, 2, 3, 4, 5, 6, 7 pieces of data. So let's try another example. If I find my 5-number summary, my lowest number here is 10 and my highest number is 26. Then I need to count the data, 1, 2, 3, 4, 5, 6, 7, 8 pieces of information, so the median, or Q2, will be right in the middle between 16 and 17. So Q2, the median, would be 16.5. If I count everything in front of that median, 1, 2, 3, 4 pieces of data, I will split that and have my Q1 number between 12 and 15. So my rusty trusty calculator would 12 plus 15, take the average of that, which is to divide by 2, so my Q1 number is 13.5. It's right in the middle between these two. Similar thing will happen on the right hand side, where we're finding the middle of what's left over. Here I'm going to count 1, 2, 3, 4 pieces of data, so 2 on each side. Here the middle is a little easier to find. The middle of 17 and 18 would be 17.5. And that's going to represent my Q3. So now that I have my 5-number summary, I can complete my box plot. The minimum is 10. The maximum is 26. So now for the box plot. I have to think of this as a number line from 10 to 26. Having a total of 16 numbers. So we'd have about 18 in the middle of it, which means to accommodate my box plot, I'm going to need to shift it down a little bit. So if I think number line, I'm going to say 13.5 for Q1 is somewhere around in there, and shrink it down a little bit to say that Q3, the third quartile, is 17.5, somewhere there, and then my median is 16.5, probably closer to 17.5 than 13.5, and I would have my box plot. I could look at the shape of this box and say that my interquartile range would give me a skewing to the left. Stretches further in that direction. And if I tried, and I do mean try, to draw the shape of the distribution based on the box plot, I would get the opposite. Because 26 is so much further away, now I'm going to get a skewing to the right on the whole box plot. So it depends on what you're looking at. I still need to find out if I have any outliers, because that really does tie into whether or not the curve is skewed one way or the other. So that might give you a hint as to what's to come. Let's use our formula for fences. Talking about the 1.5 times the IQR, it gets subtracted from Q1 and added to Q3. So here we go. For my lower fence, I'm going to be working with the Q1. Be careful not to choose the minimum, the Q1 value. So I would plug in 13.5 minus 1.5 of Q3 minus Q1, or 13.5 minus 1.5 times 4, or 13.5 minus 6, for a lower fence of 7.5. I put that with a parenthesis, and I can see my data set does not go below 10, so I have no lower fence outliers. My upper fence would be using the Q3 value of 17.5 as its most important for its starting point. 17.5 times the same values of 1.5 times Q3, which was 17.5, and Q1. So I still have 17.5, 1.5 times 4, or 17.5 plus 6, for a total of 23.5. It's going to be around here, showing me that 26 is outside my fence, making it an outlier, which is really why this is happening. Outliers skew the data in our box and whisker plots when the fences are drawn. So stop and think for a minute. If you had to explain to someone, how do you find quartiles? What would you say? Hopefully, something like this. Put the data in smallest to largest order. Find the median, which is your second quartile. Find Q1, which is the median or middle of your lower half. And then find Q3, which is the median of the upper half. If you wanted to do this in Excel, you can do that also. The numbers will be different because it's a different formula. But here's your basic outlook. You would set equals and quartile in an open parenthesis. So here's a live look. Click on any cell in a data set and type equals quartile. Open parenthesis. It asks, what's your data? That's called an array. Drag on your data. Then it asks me for a comma. And what quartile do I want? Let's say that I want the first quartile. And I hit enter, and it gives it to me. If I want the second quartile, which would be the median, open parenthesis, drag on your data, and ask it for quartile 2. And then finally, if you want quartile 3, it's equals quartile, open parenthesis, the array, one more time, is your data set, and hit 3 for quartile 3. And there you have your quartiles. These will potentially be different numbers than if you're counting them by hand. And please note there are also other ways of finding quartiles, once again depending on what text that you are using. Quartiles, 5-number summaries, into box plots with fences.